for the next presentation. Khalil is with us to talk about a web application firewall bypassing.
Yes. Hello and welcome everybody to my talk, Web Application Firewall Bypassing, an approach for pen testers. My name is Khalil Bijou. I'm working for Deloitte in the Cyber Risk Services team and do penetration tests. Well, how did I come to this topic? I was at the end of my studies, of my bachelor studies, and had to find a topic for the bachelor thesis. And at the same time, we had two web application projects, web application pen test projects, which were secured by a WAF. So it was very important for us to learn more about bypassing a WAF. And as you all know, the goal of a penetration tester is to assess a web application and find out how vulnerable it is. And bypassing a WAF is a must if he wants to do that. So, bypassing a WAF. Why? The number of web application firewalls is increasing. More and more companies tend to use them and to deploy them. The problem is that WAFs make a penetration test more difficult. So they are our enemy as a penetration tester. And attempting to bypass a WAF is very important, as I said, to get to know how vulnerable an application is. So again, summarizing, what was the main goal of my bachelor thesis, of my research, of this talk? It is to provide a practical approach for penetration testers, which helps to ensure accurate results. So let's directly dive into web application firewalls. First of all, why did we need web application firewalls? In the old days, companies just used firewalls and intrusion detection and prevention systems. The problem with these is that they operate on the transport or the network layer. So they were inspecting packets. And inspecting packets is not an easy task. So what we needed, and the problem of them also was that they had many false positives, or they were very weak. So what we needed is a firewall which operates on the application layer so that it understands traffic much better. So what does a WAF do? It protects a web application by adding a security layer in front of it. And it stands between the user and the server and inspects the traffic. If it finds malicious traffic, it blocks it. Let's come to the functionality of a WAF. So, at the beginning we have an incoming request. After the request has reached the WAF, the first thing that happens is that the preprocessor runs. The preprocessor decides whether a request will be processed further or whether it will be directly forwarded to the web server. After that, normalization functions are applied. So there are many different forms of input. We have hex encoding, we have URL encoding, and so on. And to normalize it and standardize it, we need the WAF applies normalization functions. After that, the input is validated. So the input of the user is run against some rules, and if there is a match, the input is either blocked or forwarded to the web server, as seen in this last step. Yes, let's dive into the normalization functions to get an idea of them. What is the purpose of normalization functions? One of them is to simplify the writing of rules. So if we have an administrator who is administrating a WAF and he wants to write some rules, he doesn't have to learn about URL encoding, about hex encoding, and about all the different encodings that are available. but he just needs to know about the ASCII letters. Yes. So, for example, we have here 4 different normalization functions. They are used by Mod Security, which is a very famous open source web application firewall. For instance, we have the function compress whitespace. The compress whitespace function converts every whitespace character, like end of line or new line and so on, to a normal space. We have the hex decode function, and as it states, it decodes a hex encoded string into ASCII. We have the lowercase function, which converts all characters to lowercase. So if I want to write a rule, I don't have to think about uppercase and lowercase letters. And we have the URL decode function, which decodes a URL encoded string. Okay, there are a lot more functions, but just to get an idea, I've chosen the most easiest one. Okay, coming to the input validation. For the input validation, it is important to know that WEFs use different security models. And the security model defines how the rules are processed or how the rules are used. These rules mostly consist of regular expressions. And there are 3 common security models, or these are the 3 that are available. There's the positive security model, the negative security model, and a hybrid model. Maybe, first of all, what is a positive security model? What is a negative security model? The positive security model is maybe also known as whitelisting. So to summarize, what does it do? Deny all but known good. So we have a list of good input, and every user input that comes to the WEF is tried to be matched with these rules. If there is a match, then the input is forwarded. And if it is denied, then and if there is no match, if there wasn't a rule that applies on it, then it is denied. The advantages of a positive security model is that it prevents zero-day exploits. So if there is a new exploit on the market, if there is a new exploit found by a hacker, probably it won't be useful against a positive security model because we have defined what is okay and everything that isn't okay will be denied. And it is more secure than a blacklist model. Okay? We will just in a minute talk about the blacklist model. The problem with the whitelisting model or the positive security model is that if you want to write rules for the WEF, you have to know what an application does, how it works, and you have to know every function and every parameter and write rules for it. So you need a very comprehensive understanding of the application. And the second and also big problem is it is very time consuming. So if someone wants to write rules for an application, he will need a lot of time, and he can use these rules only for this application. Then we have the negative security model, which is also known as blacklisting or blacklist. To summarize it, allow all but known bad. So we have a list of bad payloads, of bad inputs, and every user input we try to match every user input with this list. If there is a match, it is denied. And if we don't have a match, it is forwarded to the backend. What is good about the negative security model is that it mostly comes shipped with a WEF. So if you get a WEF, for instance, Mod Security, or buy a WEF from a vendor, you get a blacklist automatically with it. Another thing is that you can adopt it very fast. So you just have to deploy it, and it will it will work. Also, you don't need to know a lot about it. You don't need to know anything about writing rules or regular expressions. You can just deploy it and use it. And a very big advantage is that it can protect several applications at once. So let's say you have a web server with several applications. Then you don't have to write rules for every application, and so you save a lot of time. The problem with the blacklist is that it tends to false positives. So we might have a user who is typing in something very normal, but it gets blocked by the web application firewall. And then the usability is decreased, and as you know, there's always a stare down between usability and security, and we have to find a good middle. The other thing is that it is resource consuming, because you have a very big list of payload. You know that JavaScript and SQL, for instance, is very flexible, and you can use a lot of different forms for an SQL injection or a JavaScript injection. So you have a very long list, and if you use a web application firewall which is also on the web server, it might be a problem. Okay, let's come to the bypassing methods and techniques. So the first thing I did was to categorize the methods and techniques to get a better overview. We have 3 different categories. The first one is the preprocessor exploitation. The preprocessor exploitation, in this category, we try to make the WEF skip the input validation. So we send our input, and the WEF doesn't even try to validate it, but forwards it directly to the web server. In the second category, we have, it's called impedance mismatch, which is maybe not directly easy to understand, but what does it mean? It means that we try to find an input that the WEF interprets different than the backend. So there is a mismatch between the interpretation of the WEF and the interpretation of the backend. And in the last category, and it is the one I think which is the one with the most success, is the rule set bypassing. So we try to find a payload that is not known to the WEF and then bypass it. So let's get to the examples of some methods and techniques. First of all, preprocessor exploitation. This technique is called, or I've called it skipping parameter verification. For instance, we have PHP, and PHP removes white space characters from parameter names. So if we have this request, as you can see, we have a %20, which is a space, URL encoded, and then product ID. What happens at the WEF? The WEF sees space product ID. Then it tries to match it with all the functions in the whitelist, or the parameters in the whitelist, and doesn't find any. And then it forwards it to the backend. And what does the backend do if we have PHP? It just removes the space and sees product ID and interprets it. The same thing is with ASP. ASP removes person characters if it is not followed by 2 hexadecimal digits. So also here we have a % and then product ID. The backend sees product ID and the WEF sees something else. It sees % product ID. So if we have a WEF which does not reject unknown parameters, we might have found a bypass. Another thing is IP address spoofing. A WEF may be configured to trust certain IP addresses. And if a request comes from a trusted IP address, it does not even validate the input, but just forwards it directly to the backend. So if the web programmer or developer did a mistake and tried to retrieve the IP address from one of these headers, then the WEF will also be bypassed. Why? Because these 4 headers, the X originating IP, X forwarded for, X remote IP, and X remote address, are all in control of the user. So I can just add them to my request, add an internal IP address like localhost or 127.0.0.1, and hope that the WEF trusts my request and directly forwards it. Another technique is the malformat HTTP method. So if a web server is misconfigured and accepts malformed HTTP methods, as shown in the example. Hello 123. I don't have get or post, but hello 123, and the web server answered me with the status of 200, so it was okay. So if a web is configured to only inspect get or post parameters, it can also be bypassed with this method. And the last example for this category is overloading the web. So what we try in this step is to just send so many requests that the web cannot handle it anymore. And especially embedded web application firewalls are sometimes configured in such a way that if the load on the web server is very heavy, that it just skips input, so that it just skips requests if it cannot handle it anymore. Why do they do that? To not decrease the usability. So what we can do is just send a request with a malicious input very often and hope that some of it will pass through. Okay, let's come to the second category, impedance mismatch. Again, the impedance mismatch is the attempt to make the web interpret our input differently than the backend. One very interesting method I find is the HTTP parameter pollution. The HTTP parameter pollution is sending a request with a number of parameters sharing the same name. For instance, as we have in this request, we have the first parameter product ID equals 1 and product ID equals 2. And if we test this on different technologies, we will see that they interpret this request differently. For instance, ASP.NET concatenates both with a comma. So what it receives is product ID equals 1, 2. JSP uses the first occurrence, so it receives the 1, and PHP uses the last occurrence, so the value is 2. How does that help us? Let's take the following payload. Select 1, 2, 3 from table. I think every web that is on the market will block this input, as it is clearly SQL, and it will think, there's an SQL injection, I'll block it. But what happens if we divide this input? We send product ID equals select 1 and product ID equals 2, 3 from table. What does the web see? The web sees product ID select 1, tries to match select 1 with its rules, and does not find a match, and then tries the second parameter 2, 3 from table, tries to match it against the rules again, and does not find a match. But what happens at the back end? If we have ASP.NET, both values will be concatenated with a comma. So in the end, what the backend receives is this payload that would have been otherwise blocked. And this was a bypass of, I think, in 2009 of mod security. So that might help you. Another very similar technique is the HTTP parameter fragmentation. Here we try to split our payload, our injection or our cross-site scripting between different parameters. First of all, let's assume that we have this SQL query in the back end. We have select from table where UID equals and then our input, and PID equals and then again our input. So what we can do is, for UID, we send the payload or the input 1 and then space, which is a plus, which can be used. A plus can be used for a space in many browsers, so it's a space 1 space union, and then the beginning of a comma, and then PID, the end of a comma, select 1, select 2, select 1, 2, 3. So what happens at the back end? The back end receives the following string, 1 union, and then a comma, so it does not interpret this. And then 1 union selects 1, 2, 3. The WEF only sees this payload 1 plus union and or space union, sorry, and sees this payload select 1, 2, 3, and tries to match every value against the rule set. Doesn't find any match, so it forwards it to the backend, and the backend interprets it like this, and we have our SQL injection. Okay, and the last example for impedance mismatch is the double URL encoding. As you know, the WEF uses normalization functions to standardize the input. And the WEF, if it finds a URL encoded string, what it does is that it transforms it into ASCII. So what we can try and hope for is that the WEF decodes the URL encoded characters only once. So we double URL encode a character, for instance S. If we encode S, we get %73. What we then do is to convert %73 again in URL and get %25, %37, %33. If we now add this into our payload, 1 union select 1, 2, 3, and substitute the S with our double URL encoded S, what we can hope for is that the WEF URL decodes it once and then gets a %73, forwards it to the backend, and the backend then URL decodes it again, and we have our payload. Okay, and the last category, which is quite simple, but which is, as I think, the most successful one, is the rule set bypassing. So for the rule set bypassing, we have two main methods. The first one, which is very primitive, but is the brute forcing by enumerating payloads. So you have a list of XSS payloads and a list of SQL injection payloads, and you just send them and hope that one of them will work. Won't be very successful. But the second method is maybe the most successful one, is the reverse engineering of the rule set. The reverse engineering of the rule set, so where we try to find out how does the rule set of the WEF look like. And if we know how the rule set looks like, we can then attempt to find an exploit or a payload that isn't blocked. So based on this approach, based on these techniques, I have developed an approach for penetration testers. So they are very similar to the phases of a penetration test, starting with the reconnaissance phase and at the end the post-exploitation and so on. And these phases are divided into 6 phases, but we have a phase 0, which may not always be possible. Does anyone of you have an idea what phase 0 might be? What should be the first thing a penetration tester should do if he has an application with a web application firewall before it? Please.
Maybe some kind of fingerprint.
Okay, that's very good. But even before that, before I fingerprint and before I gather information.
Agreement.
Yes, correct, but and after the agreement? Huh? I didn't understand it. Let me just tell you, he tries to ask the customer to disable the WEF. Very easy, right? No, but seriously, what is the main objective of a penetration test? We try to find out how vulnerable a web application is. And what is the best way to do that? To test. What is the best way to do that? To just test the web application itself. So, if we test the web application itself, what can we do? We will find security vulnerabilities in the application. And if we know where the vulnerabilities are, we can then later, if the WEF is again on, if the WEF again is enabled, we can then focus the vulnerabilities much more. Yes. Yes, as I said, it might not be realizable in every penetration test, but we should try it. So, if we have done this, the next phase is the reconnaissance phase, where we try to gather as much information as possible about the WAF and the web server and so on. It is the basis for the next phases, so it's very important. And we try to get information about the web server, about the technology, about the WAF vendor, which WAF is used, about the security model, is it a whitelisting model, is it a blacklisting model, and maybe even get some internal IP addresses to try to spoof our own IP address. After that comes the second phase, which is attacking the preprocessor. So if you find, okay, again, the objective is to make the WAF skip input validation. If we have found a way to make the WAF skip our input validation, then we have won, because the WAF is then useless. We can just type in everything that we want and the WAF just skips it. To do that, we try to identify which parts of the HTTP requests are inspected by a WAF and which not. For instance, I had once a WAF where the cookie parameter or the user agent parameter was not inspected. So I could put in everything that I want. Okay, that's the first step. If you then find a vulnerability, or if you find an application that uses the user input or the cookie to, for instance, update the database or something, then you might find a bypass. So what we try to do is we send requests with a payload in it, and we change the position of the payload and see what is blocked and what is not blocked, and then try to attempt an exploit. Okay? The second one is to find an impedance mismatch. Again, we want to try to find an exploit or a payload that is interpreted by the WAF differently than the backend. And very important for this phase is to know about the backend technologies. So as I said, if we know there is ASP.NET, we can try HTTP parameter pollution, for instance. And then the fourth phase is bypassing the rule set. We try to find a payload that is not blocked by the WAF. So the first attempt, as I said, is brute forcing, and the second attempt then is the reverse engineering in a trial and error approach. What we try is we send different symbols and different keywords and look what is accepted by the WAF and what is not accepted. Okay? If we know what is accepted by the WAF, we can then try to find an exploit. Phase 5 is finding other vulnerabilities. So I've tested the application itself without a WAF, then I have tested the application with the WAF and tried XSS and SQL injection. And at the end, what I still can do is to find vulnerabilities that cannot be detected by the WAF. For instance, a broken authentication mechanism or privilege escalation and so on. So if there is a mistake in the source code, if there is a logic mistake. And phase 6 is after the pen test. What we do now is we inform the customer about the vulnerabilities that we have found. And what is very important and what I want everyone to take with him is that the best way to fix a vulnerability is to fix the root cause. So if I have an XSS vulnerability or a SQL injection vulnerability in my application, then I should change the application itself and not just add some rules to the WAF. Because SQL and JavaScript are very, very flexible languages, and to cover every possible bad input is a very hard task. So if we know, and for the time being, while the source code is fixed, there should be rules to virtually patch the vulnerability. So we add rules to the WAF to fix this vulnerability. And everyone should tell his customer that a WAF can help to mitigate vulnerabilities, but it cannot fix it 100%. Yeah. Coming to WAF Ninja. WAF Ninja is a tool I have written. It's a command line interface tool written in Python. It automates parts of the approach, so you don't have to do everything manually. We have already used in several penetration tests, so you might still find some bugs, but I hope that the biggest bugs are fixed. And it supports HTTPS connections, get and post parameters, and cookies. The most important function of WEF Ninja is the fuzzing function. In the fuzzing function, the fuzzing function automates the phase 4 of the approach, which is sending different symbols and keywords, analyzing the response, and displaying it in a clear and concise way. So at the end, you hopefully have all. I mean, no one of us can test 150 JavaScript functions in a penetration test, and no one wants to do that. So that's why we automate things. And the fuzzing strings can be easily extended with a function called insert fuzz, and the fuzzing strings can be shared within a team. Yes. So what I want to do is to show you the tool very quickly. Okay. Okay, great. So what you see here is a application called Damn Vulnerable Web Application. So some of you might already know it. It's an application which contains vulnerabilities. For instance, we have here a reflected XSS. I can then type in my name, which is Khalil, and it says, hello, Khalil. But if I try to insert something malicious, I get blocked by the WEF. Okay? This is the Web Night application firewall, which is an open source firewall. It's an old version. I have talked with the developer and they have fixed the vulnerabilities I will show you right now. So we're good to go. So we have our tool, wefninja.py. So we fire it up. And as I said, it has more functions, but we will use the fuzz function and open up the help file. Here we have to, so start from here. We have to provide an URL. So we do -u and type in the URL. The position where we want the payload to be has to be substituted with the keyword fuzz in uppercase letters. After that, we can use a post parameter, but we have a get parameter, so we don't need that here. We have to define our cookie. Okay, I have already copied it into a text file, so we can save time. Oops. Okay. Now, okay. Then we have the type of input. What do we want to try? SQL or XSS? In this case, we have a reflected XSS, so we try XSS. Makes sense. We have the delay option. Some webs are configured in such a way that if there are too many requests in a very short matter of time, then all requests will be blocked. So we can add a delay of 5 seconds, 3 seconds, or whatever. For showing, I'll just use 50 milliseconds. And we have to define an output file. So we have results.html. Okay, I think we're good to go. Let's start it. Yes. And as you can see, the program now sends all the fuzzing strings. Oh, it's okay. Yes, output saved to results.html. Let's open up the file. Okay. Ooh. Okay, the scaling is not too good. Let me try it in Chrome. Too bad. Okay, let me try another file. the scaling is, oh, okay, you see it, sorry. I was looking on my screen and it didn't show the last column. So, okay, perfect. Then let me open up what I just did. Presentation. Okay. Great, perfect. Okay. So what you can see here is, I'll make it bigger, sorry. Okay, great. I think now everyone can see it. On the left, we have the string that was sent to the web server. There we can see what HTTP status came back. And as you can see, it's 999. That's the response of the web application firewall. So what does the tool do? It says working, no. Then we have other fields like content length to further analyze it, and two other columns which are a little bit complicated to explain, so I will just skip it from here. But what is important to know is this is our payload, this is our HTTP status that we got back, and the answer, did it work or not? Yes, and as you can see, the script tag was blocked, as we have also manually verified. So what we first need for an exploit or for an XSS is a tag. So what we do is scroll a little bit down and a little bit more. As you have maybe seen, there are 157 payloads or keywords. So yes, for instance, we have the image tag. Unfortunately, you cannot see it all, but I'll just copy it here. Okay. So the tool says it works. We can try it out. And yes, it works because we are not blocked. So what do we need now? Any ideas? On error, very good. Let's look whether on error was blocked or not. Okay. On error. Okay. It's again very small. Okay. As you can see, on error was blocked. So what would we normally do? We would try other JavaScript functions. What does the tool do? It tries 150 from the beginning and tells you whether it worked or not. So there are some JavaScript functions which worked, which you can see here, but they are very difficult to execute, or it only works in some environments. But I have found one function which worked, which is on wheel. Yes, on wheel. On wheel is a JavaScript function which is executed if you turn the wheel. So what we can now do, or what we should do, is add to our payload on wheel equals. And now we also need a JavaScript function. Who knows one? Alert. Very good. I'm in the right place. Okay. Okay, we're good to go. Image source is X, so there will be, yes, X, and on wheel equals alert1. So we try that in there, put it in, and turn our mouse wheel. And as we can see, the XSS was executed. Thank you very much. So what I just wanted to show you, I did it now in 5 minutes, but for the because I know how the payload looks like, but the Web Ninja will help you find such payloads very easily, as it helps you and automates very many steps. Yes, and I've reported this vulnerability and some other SQL injection vulnerabilities to the vendor, which is AQ-tronics, and they even rewarded me with some money, with a bounty. So you can go on and try to find some vulnerabilities, and maybe you will also get some money. Okay, great. I think that's it from me. I'm happy to hear your questions, if you have some.
Thank you for your interesting presentation, but you didn't say where we can try your WAF Ninja, where we can download it.
Yes. I will soon upload it on GitHub, so hopefully you can use it and even contribute to it and add some functions.
Okay, thank you.
Okay, perfect.
Can you say your nick on GitHub?
Excuse me?
Can you say your nickname on GitHub?
On
Can you say
the
your nickname on GitHub?
on the cup?
On the GitHub.
GitHub. I don't have currently one. So let's do it the following way. I will upload it, and then you can just Google for WAF Ninja, and hopefully you will find it.
Are you going to participate in WAF bypass contests here on PH Days?
I've seen it online, but I didn't participate until now. But I want to. Yes.
And you will? Will you?
I want to. Yes.
Okay.
Yes,
Thank you.
I think so.
Excuse me, tell me, please, do you have any chat sheets about what technique can bypass any firewall? For example, mock security is bypassed by that techniques or something else.
What I have is my paper, my bachelor thesis, which you can all request. and I'll send it to you.
Where we can get this?
I didn't publish my bachelor thesis, but you can write me an email and then I will send it to you. You just write down my
Okay,
email and then I will do
okay,
it.
okay.
But there are sometimes paper. For instance, there was a XSS cheat sheet of a guy called Mazin Ahmed, and he found a lot of bypasses for different WAFs and published it. So that's maybe one thing that you want to look up. Mazin Ahmed.
Okay, thanks.
Excuse me, does your application works both with ASP and PHP? Yes?
Yes, it just sends the request with HTTP, and what is on the back end is irrelevant. So yes, you can use it against every application.
It's important for it to define on what base is built the site. How would define the text? It doesn't use PHP or ASP.
So what my tool does, thank you for your question. So what my tool does is to just send fuzzing strings and payloads. So as you can remember, the fourth phase, which was bypassing the rule pass, the rule set of the WAF, that is what what the tool tries to attack. The phases before it, like exploiting the preprocessor or like the function, the HTTP parameter pollution with ASP.NET, that are things that aren't covered by tool, which you have to do manually. So it's irrelevant for the tool what technologies are used on the web server. It's just important what comes back. Is it blocked or not? Yeah. Thank you. Great, guys. Then thank you very much. Nice discussion, and I hope you enjoy the event. Bye.